Hey everyone, today we're going to be building a REST API using TypeScript and Postgres. So first of all, a few prerequisites. You're going to need to have NodeJS installed on your machine. You're going to need to have Docker installed. We're going to run Postgres inside a Docker container, so we won't need to install Postgres directly on your machine. We're going to use Docker for that. And then we're going to be using TypeORM as our ORM. And this is just going to make interacting with the database from our Node.js application much easier. So first of all, let's just verify that we have those installed. We can do that using node-v to check node, docker-v to check docker, and then we're going to install TypeORM using npm i-g TypeORM. The -g here is just a global flag, which means that this dependency isn't associated with any single project in particular. It's going to be installed globally on our machine. So now that that's installed, we just have an empty project over here. So this is just an empty directory with nothing here yet. We're going to run TypeORM init. We're going to pass in the database flag, and we're going to say that we want to install Postgres as our database, and we also want to install Express. And passing in this flag is going to make TypeORM create a simple route for us as well. Alright, so that's initialized our simple project here. First of all, we're going to take a look at the package.json. So we can see it installed some dev dependencies for us, some dependencies, and we also have these scripts. So the main one that we care about here is start. So we can try running npm run start, and this is going to fail first of all because it obviously isn't able to connect to Postgres because we don't have Postgres running anywhere. So I'm just going to create a new file called docker compose.yml, and in this file we're going to be able to start all of our dependencies that we need for local development. Obviously, in a production environment, we're going to have Postgres installed in a different way. Maybe we're going to use Heroku, we can use an add-on. Maybe we're going to have Postgres running in AWS or some other cloud provider. But for local development, it's very handy just to have Docker run your dependencies locally. So this is just a simple Docker compose file. We have a single service for now, Postgres, and we're going to pass in two environment variables, the user and the password. We also have this port mapping, which is going to map our local port 5432 to 5432 inside the container. So this is going to allow us to be able to access this port from outside the Docker container. So our Node.js application is going to be able to access that. So now if we run npm run start again, we should get a different error. So we haven't actually run docker compose up yet, and this is going to start the services defined here. So we're going to run docker compose up -d, and the -g is just going to run this as a daemon process in the background. So now that that's finished, we should have Postgres up and running. So if I do npm start now, we should actually get a different error. So instead of connection refused this time, we're getting this auth failed error. So here, if you remember, we defined our user and our password to just be Postgres. This is going to allow us to look at this file called ormconfig, which basically defines your connection settings to your database. So here we can see the username, password, and database are defined as test. I'm just going to copy this, and I'm going to change test here just to be Postgres and save. Here we can also see that the port is fine, that's 5432, that's the same as what we defined. There's also some other things happening here. We're not going to worry too much about them yet. We're just going to get started. So if I run npm start a third time lucky, we can see now our application has started successfully, and we can see that the Express server has started on port 3000. We can open this URL to see what that looks like. So we can see here, localhost 3000 users, we have these 2 users so far. And that is because in source and index.ts, by default, TypeORM is creating these 2 users, just to show us how that's done. So for now, I'm going to delete these 2 users. Well, I'm going to delete the creation of these 2 users. And I'm going to save, and I'm going to restart my application. And we're going to see something a little bit interesting here. So we've restarted our application, that's fine. But if we go here and we refresh, we're going to see that we still have these 2 users. So whenever we stopped our application and restarted it, this didn't actually delete any data that was there. This just stopped our application and started again. We still had our Postgres Docker container running in the background, so it never actually stopped. So it still contains all the data it contained before. So just to show you how we can kind of clear that, if we run docker compose down, this is going to bring down the Postgres Docker container, so it won't be running anymore. And now if we were to do npm start, our application should fail to start because of this connection refused. We can bring the Docker container back up by running up, and whenever we start our application this time, there should be no data there because we're not going to create it anymore. So if I run npm run start, this time running on port 3000, let's see if I refresh. So now we have no data there, no users. And this is going to allow me to show another route that TypeORM created for us. So as well as this get route, we have this post route, which allows us to create users. We need to provide a first name, a last name, and an age. So if I create this single user, we can see we got a status 200 back. And if we go back here and do a get, we can see that our user is there. So we have some of our CRUD operations here, and we're able to start seeing them. So out of the box, TypeORM gives us some nice things. There's some parts here which I actually don't like so much. For example, the error handling and things like that. So if I was to send a request but didn't include the age, for example, and just send something unique here and hit send, this is just going to keep spinning, and we aren't actually going to get any feedback here. Really, we should be getting a response back here that says it's a bad request because it doesn't include all the data we need. But if we look at our logs in the background, we can see that we just are logging this error saying that null value in column age violates non-null constraint. So this obviously isn't ideal. We want to be able to handle those errors in our application and bubble the error up to the user just to let them know what was wrong and what they should be including in their request. So in the next video, I'm going to be writing some new API routes to handle some different kinds of resources. And in those API routes, I'm going to try to build more of this robustness into the API, including things like error handling. We might also go into writing some tests for the API and different things. I'm just going to create a series of videos to take this project to the next level. So if there's anything in particular you'd like to see, please let me know. But otherwise, I'm just going to try and do a couple of things. So thanks for watching, and I'll see you next time.